doing again the outlier test, okay? So there are three things. First one was what? You look at your slide. What is it? You tell me. First outlier test is, here we go. Then I'm gonna, so what is the first one? You tell me now. So first one is testing outlier. First one, outlier test. There are three different things that we did. Number two was box plot. Number three was z-score. What was the number one in that slide? Extreme values. Okay, so look at the extreme value, do the box plot, and then z-score. Three different ones. Got it? So and if you go to that PowerPoint that we have, it's on page 27. Right? So how do we do that? That extreme one. This is the one that we did, outlier test. That was the testing extreme values. And then when output comes out, I will tell you which one, okay? Okay, continue. And then we will go to plot, then do both so that we can see histogram as well as box plots. Then this is the one giving you KS and the QQ plot. Okay. But we're not, that's for the normality test though. Okay, why it's acting weird. Okay, continue. And options, now you understand the list wide and a pair wide, exclusion of missing data points. Okay, continue. And then I will paste it. So you're supposed to paste it. And I'm gonna just say, yes. So here I did everything including normality test. But for first one, extreme data point, where do you look at it? Here, extreme values. Do you see that? 1 to 5, 1 to 5. And then I don't have that extreme one because this data set open right now is outlier removed one. So that outlier is removed. So I don't see those. But through here, I can see everything looks fine. Okay. Then number two, in that slide is a box plot. So let's go down to look at box plots of it. Day one, clean, right? Then day two, oh, cluster of them. I don't have a little like a stars, extreme ones, but we have a cluster of them. Maybe some of them could be problematic. Day three, only one. Got it? That's a box plot. Then now we need to create z-score. Where do we go? Analyze, descriptive, standardized values as a variable. That gives you a z-score of day one, day two, day three. And let's see what options do we have. Okay, I want this, all right. Oh, we could do kurtosis and skewness here if you want, but I won't do it here, okay? And I continue. Then paste for you. Then I will say, okay. Then I go here, 1 to 3 days, z-scores. Then with the right click, you just say descending or ascending, but descending so that you can see the top. Oh, all of them are below 3.0, so fine. How about this one? Descending again. Oh, couple, 3 of them are above 3.1. How about this one? Descending again. Ah, 1 here, then ooh, this one, look at this one. There is 1. Now you need to speculate that particular person. Ticket number 4564. And then you need to make a decision what you did and why. Right? That's outlier test. Extreme value, box plot, then z-score, and then by 3 days report it. That SNS gives me buzz like that. And what is it? What is the mean score of the person? Ooh, look at this person. It's what is the scale? Is it 0 to 4 or 1 to 5? I had some of you saying 1 to 4, 1 to 5. No, that's wrong. Okay, it's 0 to 4. And this person throughout the days, almost a 4. 4 means what? When you look at person's score, was a 3.38, 3.44, 3.41. So it's a 0 means what? Smelly like?
Good.
Really good.
Flowers.
It's really bad, right? Okay. 0 is bad. And 4 is what?
You smell good.
Yeah, you smell good. And this person says, throughout the day, I smell good. And that range is 0 to 4. It falls it in right there. Then you look at expand yourself when you speculate data. Look at gender. Is it male or female?
Female.
It's female. 1 is female, 0 is male, right? So I don't want to put male down, but female tended to keep themselves pretty clean over some days. So you could say that, little biased description. Female tended to keep a little bit cleaner over 3 days. So then it's possible response 0 to 4. That's why you kept it. Or you could remove it with the justification if you have a good one, right? Okay. So understanding data is key. What is this data is about? What that 0 means and 4 means, and what that 1 for gender means and 0 for gender means. So before you start analyzing, jumping into like clicking the SPSS, have a good understanding of the data. That's really important, okay? All right. So that's the outlier test. Questions? So this one actually, like I said, it's outlier to remove the data. So it's pretty okay to keep it. Now, we are going to the second one, normality test. So first one, normality test, what do we use? QQ plot or PP plot, right? QQ plot comes out with KS test. PP plot, I have never shown you, but I will show you this time. Analyze. You will see this one is exactly the same as a textbook. Descriptive, do you see that here? PP plots? Yeah.
Mm-hmm.
If you want PP plots, put 3 of them and paste it and run it, then you will get PP plot. Here we go. Oh, day 1. Look at, almost similar. So it's very normal. You don't have to worry about descending one, detrended one, okay? Look this one. In the middle, it's a little bit off. So maybe not normal. Day 2. How about day 3? Oh, maybe not normal. All right, let's check KS test. It's a visual. This one is a visual, okay? So then we did a KS test already. So I'm gonna just go up. Where is it? I think it is somewhere around. Did I pass it? It's somewhere around here. 8. Oh, right here. Do you see that here? Day 1. Statistic is, so D equals, and N is what? This one, what is the N? 809 in the parentheses equals 0.089 p-value. Oh, I did something wrong here. Look, degree of freedom is all 123, which means I use the least wide thingy. Okay, let me just get rid of it.
When you say use a list wide, do you mean like the list versus the pairwise?
That's why I have 123 for all three days, because it was least wide removal of missing. So I'm gonna go back here and let me check. Yes, it was least wide. Yeah, because the degree of freedom sounds really weird. Okay, continue. Then I will do okay. All right, so then I'm gonna go down. Oh, here, right here. Yeah. Do you see the degree of freedom right here that you need to report in that KS test results? 1809, 263 for second day, third day 123. Right there, you pick it up from there. P-value, whenever you see from SPSS, seek, significance or seek, that's a p-value, okay? So when you look at p-value here, not significant for day 1, which means it confirms right here too. Pretty staying together, right? But when you look at even PP plot the earlier, it was a significant. KS is significant. QQ plot was like that a little bit. right? So that's something that you need to pay attention. So here is the thing: when and then skewness kurtosis, of course, you are getting from where? Here, day one, skewness kurtosis, their values, and then standard error right here. Then day two, right here. Day three, right here. That's what you need to report. Okay, so when you look at QQ plot and then skewness, kurtosis, and KS test, overall putting that together, some say, oh, not normal. Some say, oh, it's normal. How do you make a decision? With all that, you make a decision as a researcher whether you're going to just go with it or fix the problem. Okay, so that's the researcher's decision based on it. I have been reporting a lot of skewness, kurtosis, not much KS, because my sample size always tended to be above 300 or near to 300. And if your sample size above 300, KS is not accurate. Okay, that's the one that also I laid it out in the PowerPoint. Okay, all right. So having that said, any questions? Yes, yes, Harmony, yes.
Okay, so my question briefly, when it's about the KS test, I was getting confused a lot and I had to keep taking a step back. So the significance, right? It's saying if there is a significance, then the data is normal, like it is close to the line. Okay, that's I keep messing up. Like that's what I'm thinking.
Okay, so I am going to. So after this little crash redo, go back this slide, particularly from 25, and review it, okay? And where is a KS test thing? Right here. If it's a significant, it's non-normal. Okay, do you see that, what I'm highlighting here?
Mm-hmm.
Yeah, yeah. And should I use PP plot and QQ plot? Doesn't matter. Just it's a visual thing. I mean, you're not gonna make a decision only based on QQ plot, PP plot. Okay, just look at that visually, and you're like, oh yeah, maybe not. Then you look at skewness, kurtosis with the number, and then what is that? The KS test. Then a sample size consideration. If your sample size is large enough, I would not worry about a little bit of skewness, a little bit of kurtosis, because your sample size is large enough.
So
or later on, I will say, okay, if it's not normally distributed, let's use bootstrapping, which is available these days. So that'll correct lots of problems. Ticket number. That's why I'm telling you every single time you need to understand the data. So the reason they have a ticket numbers as ID because they want to have say the same person reporting that feeling of dirtiness over 3 days, but they cannot grab 800 people on the same day, the same number of people in third day, right? So that's why they have a lot of missings like that. Overall, I would say you have 800 people here, but they have less data point in the second day, less data point further down on the third day, but your sample size is what?
I guess. Okay, that's interesting though, because I would say even though it started off with 809 and it got smaller because it was hard to track, with that mindset, I would say the days less than 300 people, for example, day 3 wouldn't matter because less people are coming because it's not originally the 109.
Some research, so depending on the researchers, they could use list wide. Boom. If you have a missing, I want to get rid of all of you, then they will have at the end of the day 123 participants. And some researchers know data matters each day. Then they will use pairwise. Then their data sample sizes change over day. So I would say this is pretty large sample size.
Okay.
Yeah. And let me tell you, what we are talking about today about like, should we get rid of it or not? And all this conversation is exactly happening amongst the researchers all the time. It's a daily language. And the other day I was fighting over this criteria. Like, it's not normal. Should we do something? And I said, no, we don't have to. We have 289. Like, it's not 300 yet. Like, that's okay. It's still large enough from my view for our analysis. But my collaborator would say, ooh, it was a 3 point something. So we need to do something, but it's not normal. So at the end of the day, I suggested let's report in the paper. And if reviewer of the paper says something, we do something. If they let it go, then let it go. And let's see how it goes. And then we put it in the paper. No one says anything. We just report it. It's slightly non-normal, but sample size is good enough, so we just moved on with it. But we reported it. Problems a little bit in there. Yeah. There is no like accurate answer for it, okay? All right. Any questions? So feel much better?
A little bit, yeah.
Yeah. It's a matter of learning, like a couple of you said in separate discussions, learning the language, how to express your understanding in these statistical terminologies, and how you improve that moving forward. When you're reading articles, pay attention how they report it, what language they use. Do not skip the results section anymore, okay? Then look at the languages that other, like samples, how to report the descriptive in APA. Just search it. Then you will see languages. The reason we have those templates, how to do it, because this is a new language for many people. They don't know how to express what they see from the number into the writing. That's the next step. You're putting yourself up. That's what you're getting trained. You learned big chunk of it, 710. You're learning 750 now with the numbers. You will repeat the 795, okay? Over 3 semesters, repeating. And then you will see yourself getting better, never become perfect.